guys. So I'm Rob Sherwood, CTO at Big Switch Networks, and I'm going to talk to you about how we actually implement some of this Big Cloud Fabric technology and actually go through a little packet walkthrough to give you guys more of an intuition of what's going on under the covers. A little bit about kind of the thinking behind this product. So what is a fabric? So a fabric is a little bit more of a marketing term. I actually stole this picture mostly from Greg Farrow. I believe the term fabric really comes from the notion of a crossbar switch, which is you actually have every input is connected to every output, and you can actually connect them arbitrarily. So you can do multicast, you can do broadcast, you can do unicast without any impact, as long as the clock cycles of this switch is going fast enough. And so people take this as a concept and implement it a bunch of different ways. One of the ways that people implement it as is a standard chassis-based multi-line card box. Like this is your traditional big iron box that you'd probably use as an ag switch. And so this has line cards, it has a fabric backplane, and it has probably 2 supervisor modules. That's how people normally implement this. So what we've done is exactly analogous to this, except for the sheet metal. Instead of line cards, we use leaf switches. They're actually even the same underlying forwarding hardware in a lot of cases. The fabric backplane is implemented as the spine switches, and your supervisor modules are actually PCs running software, and so are ours. We just call them something slightly different. And so the big catch here, and I think this is actually where the industry has gone a little bit off kilter here, is there's actually a protocol that runs between the supervisor modules and the line card. So if your BGP daemon is running on that box and it says, aha, I have a new route, there has to be a protocol that communicates the new route down to each line card so they can do the line rate forwarding. It's not like all the packet forwarding goes up through the supervisor module. I call that protocol closed flow, right? Because it is exactly what OpenFlow does, just in a proprietary way. And in general, what happens is you actually build these things with an internal Ethernet channel. So it's not like it's not even running over TCP or UDP or something like that. It's really designed to be the same thing. The only difference in what we're doing is we're actually using a standardized protocol to connect these things, and we don't make you pay for the sheet metal. And the advantage of doing something like this is you don't have to decide when you buy the chassis how big you want to make this network. Questions about this? I've said something completely outlandish, so somebody should ask me something.
In the big chassis, the ASIC programming happens across that thing you described as actually Ethernet.
Yes.
You have your fabric interconnections, the presumably 40 gig Ethernet between the spines and leaves. Where's the programming happen? So,
and this was what Ethan was asking. There's a dedicated out-of-band management network. And it's actually the same in both cases. It's just in the right case, it's something you can point to and you can see, aha, there's a switch there that I know could go down. It's a dedicated management switch. In this case, there's actually a switch internal to this that could, in theory, go down, but because it's all managed as one box, you don't ever really think about that.
That sounds scary.
Well,
why is it not scary?
So, what I'm trying to tell you is, this may or may not be scary, but it's no scarier than what you've learned to live with. So every time you've had a box die on you because it started software forwarding or something like that, what's going on is packets are going from the line card, punch it up to the CPU, and the CPU is hitting 100% CPU and dying on you. Now, that is in theory possible here. If we as programmers at Big Switch didn't know what we were doing, we could cause that to happen. And that scares people, and it should. But what I'm telling you is, by leveraging the same experience that people have been doing for the last 20 years, this is a problem that people know how to solve, and that it's actually not a fundamentally different problem than has already been solved. Does that make sense? You still look scared.
Well, I mean, so I was downstairs earlier. I saw some really inexpensive switches with 1000 base T connections to all your management ports.
Yeah.
And is that thing a single point of failure for the whole fabric?
So short answer, absolutely not.
Okay.
Letting out one of my favorite cats out of the bag. When the controller goes down, the other one takes over. When both controllers go down, the entire thing keeps running. So even if you do lose that cheap management switch, the only thing you're losing the ability to do is to change and reconfigure the network. The data plane is completely decoupled from the control plane. So all of the packet forwarding, everything that you actually really need to keep going does keep going.
So all the 32-bit routes that you described earlier for each host, they stay there and all that kind of thing.
The only thing that doesn't happen is if a new host shows up, that new route doesn't get propagated everywhere. So like new hosts are kind of screwed if both controllers are down, which is, by the way, it's already a horrible situation, right? If you're losing multiple servers out of your network, you've got some other problems going on. But we still deal with that case. And what's interesting about that case is if you think of, like, compared to this world, if you lost both supervisor modules out of your Nexus 7K, the box stops working, right? So this is actually an additional level of resiliency that we've built into this that's not even available in the more traditional world.
So for your Leaf switches, then, do you have a single management port or do you have dual management ports?
So right now for the Leaf switches, we have a single management port. It hasn't been a problem in practice. That said, there are people concerned about it anyways, and so we're either going to probably add another management port to the switch, or we're actually going to dedicate a couple of the front panel ports to being management ports.
Okay, that makes sense. And I mean, ultimately, the concern there is, all right, maybe maybe my controllers are fine, but if the switch that is powering that goes down, well, then now I've just lost connectivity to everything.
Yeah.
And that that is something that
yeah,
that's
and even if everything keeps going, the ability to not be able to manage that is problematic.
Right.
And so, really, in practice, we haven't seen that be a problem because, I mean. Okay, raise your hands. How many people still run, the cheap-ass Netgear or whatever that you have still in the critical points of your management network? Right, like all of us still do, and they actually run almost all the time. But if you do lose one, the world doesn't end. Right? I won't make people raise hands. I'm seeing smiles that everybody knows what I'm talking about.
No. The theory is that the world doesn't end when you lose your management network, but sometimes, there's sometimes someone had to solve that problem and the DNS or something ended up going across there and it screwed up something.
What we do in our office network here is we actually have another instance of Big Cloud Fabric which runs as the management network. So it turns out all of the things that are useful to have for your standard network are also useful to have for your management network. And we terminate the recursion by having the switch that there actually talk directly to the controller.
Yeah, I'm just thinking about that. They might get a bit messy. Yeah.
That is not the recommended deployment, but it's
all the way down.
Yeah. Wait a second.
Do you have a recommended deployment topology that's more interesting than a single 48-port switch?
No. Not right now. I mean, so just so everybody's on the same page, this product is in beta now, and it's going to be shipping probably at the end of the month. I mean, so this is V1. Now, V1 has actually been through a fairly extensive beta process. And by the way, the stream is actually running over the Big Cloud Fabric network right now. And so you guys can see for yourself it's actually pretty stable.
I have a question. So if you do lose two controllers, how long does it usually take to stand up another controller to recover from that? Is that?
It depends. I mean, so it depends what gets lost. Like if you actually, if you're interested in the exact detail, I actually have I have a video online that I can point you to where I actually stand up a controller very quickly. Mm-hmm. I do it on my laptop. The controller can ship either as a physical appliance or as a VM. I know what I'm doing. I can stand up one in probably about 20 minutes. Sorry, so it's about, the VM copying time is like 3 minutes, and there's like a minute of configuration. And if you happen to have a backup, that's another 30 seconds.
So just to add a sort of on a appending to that, you've got no default forwarding behavior or learning behavior. As you said, when you plug in a new device, it's out of luck with the controllers.
With both controllers down.
With both controllers down. Okay, cool.
Yeah, but that's why there's two. So the normal case of losing a controller, that can happen, and we fail over without a problem to the other controller. That's kind of, you lose one supervisor module, the other one takes over. That's the standard thing.
Well, like what a lot of folks we've seen, like when you move out of the traditional like multicast learning with things like the XLAN, it's a performance optimization to do something like unicast, because then you don't have to flood bump frames across all these tunnels. But if there's an unknown, and there's no instruction received from like a controller, for instance, it's able to still go across the fabric just using those old rules.
Okay.
Rather than the new optimized stuff, which is obviously preferable.
Yeah.
But yeah, that's the reason I asked.
And we are looking into the ability to continue to do that. Nothing that we're doing inherently prevents that. This has actually been, A, easier to implement, and B, there's actually a bunch of things where, for security purposes, you actually still want to do a little bit more intelligent learning.
Sure.
Can I just ask one other clarifying question? You mentioned in part of that discussion having the management switches, maybe eventually have a second
management port,
port. But my understanding was that Big Switch's solution was really the software that drives all this, and you're using ODM or white box switches. Is that right? So when you're talking about adding additional management ports, are you talking about working with the ODM vendors?
Yes.
Or okay,
yeah.
All right. So you guys are not. You're not supplying branded switches. The whole point here
there's no such thing, and maybe it was a mistake in the name of the company, but we do not have a Big Switch to sell you.
Big Switch doesn't Big Switch. Got it.
That said, just so you guys understand, where the name of the company comes from is actually managing this whole thing like one Big Switch. Almost like that. Good point. I forgot to point that out.
What about more than 2 controllers? A lot of vendors now, multiple vendors are doing odd numbers for sharing between them.
I don't know if you've been involved in a commercial software company. So there's different levels of what's architected for, what the code's written for, and what's tested. It's definitely architected for that. I've personally written a bunch of the code for this, and we do support that at a code level. It's not tested. So don't deploy stuff that's not tested. We're thinking about adding that, but honestly, the use cases are kind of rare there. Like we ran into apparently Japanese financial requirements require 3, and apparently if you lose 2 of the 3 and you're still up, you actually have to make a filing to their equivalent of the SEC. So it's those types of corner cases where you might need 3. It just hasn't been front and center on the radar right now.
So curious, actually, when you look at that, thinking about the odd numbers and like the benefits of that. So if you have a robust management network, potentially a controller in each management switch to disaggregate switch to controller, if that connection is lost, in a split brain scenario, is it just strictly active standby at that point, or?
So we actually have. This is getting way into the weeds, but I was involved in this and happy to answer it. If a switch is connected to 2 controllers, but the controllers don't see each other, they actually pick up a mechanism through the switch to say, hey, the switch sees both of us, but we don't see each other.
Right.
You're going to be the active controller.
Cool.
And what ends up happening in that case is the other controller actually shuts itself off to ensure that there's no confusion in the split brain world.
Okay. Cool.
So we are based off of OpenFlow, and it's OpenFlow with some extensions. That does set off some alarm bells for people, and I understand why that is. Let me make sure that everybody's on the same page for why you shouldn't be worried about this. If you look at the boxes that we have and the chips that are inside of them, they have a bunch of different forwarding tables in them. So think of it as programmable memory that you can populate. And so some of the early OpenFlow implementations only exposed things out of what I'll call the ACL table. And so there was only about 2,000 entries that you could manage. It's very hard to build a scalable network with 2,000 of anything. And so this was not at all an OpenFlow limitation. It was actually a limitation of the implementations. And so the reason why this is the people who were implementing OpenFlow first were honestly looking to explore this. They had a whole bunch of other software they wanted to run on the box that needed to manage those other tables, and they weren't going to throw away their 15 years of routing work that they've actually invested just because some crazy college kids wanted to do this OpenFlow thing. So they carved out a very small section of the ACL table and called it good. And to date, if you get an OpenFlow implementation, this is a valid OpenFlow wire level protocol implementation. It's just not useful for anything. And so what we actually do is we actually gut all of the software on the box and only run OpenFlow. And we expose a lot more tables than I can even show you here because we're under NDA with Broadcom. But we expose an L2 table, and that has 100,000 entries. We expose an L3 table. These are the tables that run your network today. Like if you have a box that has one of these Broadcom chips in it, you can do all of these things now independent of what the network operating system is, and there's nothing about OpenFlow that limits that for you. OpenFlow is really just a RPC mechanism to populate and manage these tables, just like in the closed flow case in the multi-line card system.
This is all Trident 2.
So the thing that, because I don't want to get in trouble with Broadcom, this is actually so generic that this is true across just about any chip that you can mention.
Okay. In the Broadcom family.
And even more than that. But this applies to almost every chip that I can name. Although there are companies that are starting to come out with less rigid notions of this. There's some academic papers where you can basically balance memory almost arbitrarily between different tables. I can point you to some academic papers of people doing stuff like that, if you're interested.
Yes, I would be.
Okay. And the reason why we can actually... Oh, and it kills me. Talk about things being named badly. OpenFlow does not mean flow-based programming. It should have been open remote table writing or something like that. So yes, some of the early OpenFlow implementations were flow-based networking, similar to ATM back in the day, if you guys were there with me. There are a lot of useful cases for flow-based networking. The data center is probably not one of them. And just because we use OpenFlow doesn't mean we're doing flow-based 5-tuple matching or things like that.
So, what is the rest of the industry missing on this? I'm seeing OpenFlow switches get put out there on the market, and people are excited. I think Pika 8 had one, and it's got special magical TCAM, and we can do 8K entries now. It was very excited, and but that's not exciting compared to this slide.
So, you're asking the wrong person. I have a very biased opinion here. But, so if you remember Kyle's slide in the earlier talk about the erector set, a lot of people have bought into the idea of, I'm a pretty big company, I can afford to put 5 developers full-time on this. I'm going to take a switch from one of the companies you mentioned, I'm going to take an open source controller, and I'm going to write my own networking stack. And that's great if you're Google. If you want to put 500 people on this for multiple years, then knock yourself out. You can figure out all the hard problems. And if you want to put 5 people on it for a year, and for most companies that you guys are thinking of, dedicating 5 full-time programmers on a project is probably even well out of scope for them. Like, that's insufficient. And so, really, like for Pika 8, which is a company that I love, we work with them in OCP, they are helping fulfill the erector set model needs for people who want to build their own stacks. Now, how they expose the specifics of their tables, that's up to them. And actually, it's something that I'm kind of trying to educate people about. When people say they support OpenFlow, what you really want to ask is which tables and how big are those tables? Yeah. Because the wire protocol of OpenFlow is pretty easy to hit, but the actual important bits of the standard are currently underspecified. And there is some work in the ONF table typing patterns, if you guys are familiar, where you can, at a controller level, dynamically interrogate the switch to see if you support the thing that I need you to support, but I'm not sold on it. What I'm sold on is write the switch software yourself. And that's what we can do with bare metal switches. So Lite OS is the thing that runs on our OpenFlow on our bare metal switches. So this is, if anybody's tracking Open Compute, Big Switch has a project in there called Open Networking Linux. It's basically a Linux distro with all of the stupid drivers that you never want to write for, does your I2C bus initialize correctly and tell you if you've got an SFP plugged in? Nobody should ever have to write that code like as their own Linux enthusiast. But of course, that code doesn't exist in a standard Red Hat Linux distribution. So we have a just Linux distribution that does that. And then what we run on it is basically an OpenFlow agent. We give 100% of the underlying forwarding chip. All of that forwarding memory gets turned over to OpenFlow, and that's how we get that previous slide. And yeah, it runs a bunch of other things on it, right? So it runs SNMP and it runs syslog and NTP and a couple of things you guys know and love. And if you really want, the design goal from our side is you never have to, as the admin, log into the switch. But if you really want to, or you want to debug something, you can get to a bash prompt and install stuff if you really want to. All of that's available. Questions on this?
So do you have hitless upgrades when you have to upgrade the firmware?
That's the next 2 talks from now. But yes, that is an important property.
This is pretty cool though. So in general though, when you receive the switch, right, you mount, you rack up 2 top of racks. You literally don't have to even console into that top of rack device.
Exactly. Much like, although you can, session 15 and things like that, you don't typically log into a line card.
So, question from Twitter actually, in terms of config management tools, a la Puppet, Chef, Ansible, that kind of stuff, whether it's with the switches themselves and probably not with this, because like he just said, it's sort of a conjoined thing, but any sort of integration there that you guys have been working on, any use cases that you've come across?
We've definitely come across use cases, from we're kind of two minds of it. One is both the controller and the switch run Linux. If you want to deploy that stuff on it, you guys can knock yourself out. That is a thing you can do. The other end of it is a lot of our value as a company is making sure that you don't have to, right? That all of those things are available. Anything you might want to do is available from the controller. So think of it as the
guy installing Apache doesn't want to interact with the controller.
Well, but do you want to run Apache on your Switch?
No, I don't want to run Apache on my Switch. But in terms of provisioning applications, I don't want to have to jump from thing to thing.
Well, and so the goal there is the guy who the guy who's deploying Apache might make a call into the controller, and whether that call is REST into the existing controller APIs or something like an Ansible call into like a little stub running on the controller.
Right.
That matters less to him, and it's just a matter of what's easiest.
Right.
And so, absolutely going forward, I can imagine us having some chef recipes or some integration at that level.
Yeah.
At least right now we don't have that, but at least it's all the bits are there for people to do that if they want to do that ahead of us.
Understood. My main point was if you'd run across anybody asking for stuff like that.
We have people asking us if they can do it.
Sure.
And then when we dig into why they want to do it, usually we have a REST API call that we can show them, and they're like, "Oh, that was easier." But absolutely, I imagine there will eventually be those use cases.
Yeah.
I haven't found like the meaty chunk of them such that it gets prioritized from our like PM standpoint.
Understood.
More questions? How much? What's the time? So we have. I put my cell phone away so it wouldn't ring, but it means 2 o'clock. All right, so I gotta go faster.
2:11.
Okay. So the logical router implementation. So I mentioned before that each logical router is a VRF. I forget who asked the question, but yes, this concept does get pushed down into every physical device. So every device is both a switch and a router. What this means in practice is 2 things. One, if you imagine kind of a traditional network, you usually have like a hard L2, L3 boundary. And even if you have 2 devices that are on the same physical, that are connected to the same physical device, if they're going as an L3 connectivity between them, they'll have to do some sort of waypoint route. So, in this case, even though this device and this device are physically connected to the same box, with this hard L2 boundary, you have to bounce through this. It creates bottlenecks. It creates all sorts of mess for latency. It creates additional points of failure. So if this device goes down, it's not intuitive that the connectivity between these things would go, but it does. With us, with our logical routing, everything's distributed everywhere. It actually just goes direct. Basically, whatever is the first hop actually is the router for that instance. So this is a bit subtle, but hopefully it's not too complicated. Thoughts, questions?
So you're always one hop away from everybody else in the domain?
So you always take so the way I actually say it is you always take the shortest path. And whether you have MAC rewriting and T-tail decrement, the routing step depends on policy, not topology.
This kind of reminds me of the last comment you made like 2 sections ago regarding overlays, and I know you don't want to get deep into that, but just out of curiosity, you said that it was difficult to identify tenants at that ingress point, which is weird to me because and maybe I'm oversimplifying it, but essentially you select for instance a VXLAN ID at that point. Once you have that, you have the VTEP IP address for that.
So what I really mean is from the edge of the thing that doesn't have a VXLAN ID to adding the VXLAN ID, that boundary. So given a whole bunch of packets, how do I map them onto the right tunnel? It's that gateway function that's hard to do.
Oh, like for instance, ingress is like a VLAN or something like that, having that mapping of...
And so if ingress is a VLAN and then you can only have 4K VLANs, then all of the 24 bits of VXLAN is a little bit lost for you.
Okay, and you'd prefer to do it on a physical port basis, essentially.
Yeah, well, so it's physical port plus a local VLAN.
on that port.
Yeah.
Okay.
So, which is to say, and this is another use case for the VLAN rewriting, which is to say, on port A, VLAN 100 means something completely different than on port B.
Because you don't keep that VLAN construct across through the rest of your network, do you?
And so a little bit under the covers of what happens here, we actually internally rewrite to a segment-specific VLAN, but there's other things that we can do in the background so that, as we explore new parts of the chip, maybe we do VXLAN internally, maybe we do MPLS internally, but inside the fabric,
right.
We will keep that same management concept and we'll just scale that to scale that up with whatever makes sense for your hardware.
Yeah, because ultimately it doesn't matter, right?
Yeah.
You just need a table that matches this value to this value.
And that's why our L2 label identifier and our L3 label identifier are actually strings. So which is to say it's easier for humans to understand, but you don't have to renumber if we change the technology underneath.
So if you've... go ahead, please.
I'll say it's a statement. It's just odd using the terms VLANs and VRFs here. It's confusing me, actually.
Well, apologies, and the only reason I use that is to not confuse you.
Speak of.
So, the terms that I'm supposed to be using, the proper marketing terms, are a logical segment and logical router.
Yeah, and that to me actually, given this technology, makes more sense because then I'm trying to not go back to old school, but it's just different.
Yeah, and the other reason that I use VLANs and VRFs is. There's actual specific ASIC hardware to implement some of that functionality, and we reuse that hardware. And so if you're worried about kind of a badly classical OpenFlow model where you're matching on 5-tuple tags and you're going reactive through the controller and whatnot, telling you that it's actually using the same hardware as a VLAN underneath, the intent is to make you feel a little bit better about that. It's doing the same thing roughly that's going on my network, just the management's a little bit smarter.
The logical constructs with the word logical, almost differentiates and says emerging versus just...
That's certainly the intent. You can chalk the rest of the confusion up to me trying to badly translate the new future thing to the old thing.
Okay.
So that's my bad.
So just one more question about layer 3 forwarding there. So if I've got a server in rack 1 and a server in rack 2, right, that are trying to talk, that are in different logical segments, the traffic is going to basically get routed on, say, from rack 1 to rack 2 direction, it's going to get routed on, leaf node 1A onto the segment, right, that the server in rack 2.
As it leaves there, it has
the reverse is going to get routed
tag
at the local leaf node, right? Now, in traditional networking, that can actually get you in a bad place due to if you mismatch CAM and ARP timers, you get that thing where unicast floods everywhere, right? Does that not happen here because the entire fabric has
the central controller
L2, L3 mapping with all the endpoint information? And you have a scalability problem there for the entire fabric to have L2, L3 leaf, mapping between all hosts in the entire fabric.
So you lost me on the last part. So the first part of what you said is definitely true, which is to say if you have 2 hosts in different segments in completely different racks, the routing step happens on the first hop.
Okay.
And so as it leaves that first hop, it's in the destination VLAN or logical segment. And then what ends up happening is the controller is actually smart enough. The controller has a centralized database of, these VMs or these physical switches, live off of all of these ports, and it actually has a complete global view of that.
Right. Okay.
And then it pushes that information proactively out to each box.
You have the MAC and IP address of every endpoint
at the
known
controller,
fabric-wide.
Yeah.
Well known at the controller. Okay.
Yeah.
And essentially pushed fabric-wide.
Controller.
At the controller.
Not the spine switches.
Not the So actually, in the implementation we have today, so I mentioned earlier, so we're scaling up to I think 48,000 endpoints right now. That is actually with the dumb thing of you push everything to everywhere. A very easy scale up thing for us to do is to not push everything to everywhere. If you don't have logical segment X defined on this spine, on this leaf, then don't push that there. It turns out talking to the customers for 16 racks, this just hasn't been an issue.
Right.
That's just a lot of endpoints.
Question going back to to the routing. So I'm going to try the newer names, but within a tenant, right? In different segment within the tenant, you'll route first and then switch, right? Within the rack. So if you want to connect multiple tenants, i.e., I don't want to say VRFs because I'm thinking about MPLS and route leaking and things like that. I don't want to think about that.
Yep.
So if you're trying to communicate between VRFs and those resources are physically in the same rack, do you ever leave that rack?
Yes, and so that's a small corner case. So you can think of the spine, so the system router only lives in the spine.
Okay.
So if in the same physical configuration, if the source and the destination were in different tenants, we would actually still end up in a world like this. And this is actually due to a technical limitation. So each pass through a logical router is a collection of policies. Right, so this logical router, the source logical router has a set of policies, the system router has a set of policies, the destination router has a set of policies. And the chips actually only allow you to process one set of policies as if it's through one VRF at a time. And so we actually go source router policies, system router policies, destination router policies to bounce through there.
There's that pipeline thing with the Trident too, right?
So this is actually common to many chips. Very few chips have the bandwidth to actually recirculate a packet, and usually it comes at the cost of something else that you don't want to give up.
Yeah.
And actually, in practice,
I'm
going
hearing
back,
other people are looking at like this sort of developments around that, more customizable pipelines and whatever. But yeah, it sounds like it's the same problem everyone's got. Yeah.
Well, and if you go back to kind of like the multi-line card world, it's actually the common case routing inside a multi-line card that you bounce through the fabric. Even if it's completely local to the line card. And so what ends up happening is the spine is so over provisioned that it's just not usually an issue.
Are there any special design considerations for multicast?
At this layer, not really. So multicast, there's really two parts of it. There's the data plane aspect once you've already figured out your trees, and then there's the control plane parts. The control plane parts, just like in a traditional chassis-based system, all of those would run in the supervisor module in the controller. And then once it figures out what the trees are, it actually pushes the forwarding rules down into the individual switch, individual line cards and things like that. The other thing I wanted to hit before we move off of this, and I may have to skip my demo, makes me sad, is the other aspect of a logical router is the gateway address is virtual, which is to say it actually exists on every node. So if you remember, from here to this router, there has to be a .1 address somewhere. And so if this node is in the same source segment as this, when it goes to its routing step, this same .1 address logically exists in the other router as well. And so what ends up happening is that this logical router is distributed everywhere in the network, both from a routing standpoint, but also from like an IP standpoint. And so you can think of this as every port is able to route to every other port. And so I like to joke this is like a 16 terabit router, because you could go full line rate across all the ports. Which, I mean, that's a non-trivial statement, right? I mean, think about back to the line card, multi-chassis end of the world. I mean, how many boxes of this size can you actually get to do that?